What is a dataset? Dataset is a collection of objects and properties associated with these objects. And usually we deal with data frames in the form of a table. A table. Table has rows and columns. First row is usually a header, and each other row represents an object. And columns represent properties associated with these objects. Each object has a unique identifier, ID. 1, 2, and 3, for example. And let's imagine that our objects in this table are customers. That's our customer ID, and we have some properties of our customers in this dataset. It could be some simple properties like name or age. And they could be more interesting properties like number of transactions, for example. Number of transactions. Or lifetime, for example. Lifetime. For how long this customer has been with us. So that's what a dataset is. A collection of objects, customers, and their properties. Name, age, number of transactions, lifetime, etc. And the problem is that database by itself has no datasets. Database only stores the data, and it does it in the format that is convenient for storing. And in order to have a dataset, you have to build it by yourself. And you can do it only by using SQL. In this video, I will show you a number of principles for building datasets in SQL. The first principle is define a starting point. Before building a dataset, you have to decide what collection of objects you're gonna work with. You have to select a portion of customers, in this case, from your database, the portion of customers that you're gonna work with, you're gonna build dataset for. Technically, you have to find a number of IDs you will be dealing with. And you may, for example, decide to work with 1,000 particular customers from your database. And you may store them in a table, or you may just write a SQL query that selects these customers. And this table or this query will be your starting point. Before starting to build a dataset, you have to delimit a number of objects you want to work with. That's a starting point. All objects you include in your dataset. The second principle. Left to right. What does it mean? It means that you build your dataset from left to right. That's the direction of building, like this. You start with your starting point, the collection of IDs, and then you start to add properties of your objects one by one. Name, then age, then number of transactions, then lifetime, and so forth. And the direction of this building is from left to right. That's a very logical direction. And I like to make it explicit, because in my experience, a lot of times I've seen that people violate this logic and they build their data sets in whatever direction they want. I think that you have to respect this direction, have to respect the logic, and build your dataset from left to right. It is the most intuitive way to think about the direction of building a dataset. Next principle. Only left join. You don't need any other joins to build datasets. Left join is good because of two reasons. First one, it allows you to follow this logic from left to right. That's the first reason. And the second reason is that left join preserves all objects from your left table. And your left table is gonna be your starting point or your current dataset where you add new feature, new column. And you don't want to lose any objects from your starting point. And left join does exactly that. For example, if you calculating a number of transactions for each user, and some of users does not have any transaction. In this case, if you use left join, you will end up with blank or null for this user. And you don't want to exclude this user from your dataset. And this exclusion might happen if you use inner join, for example. Inner join leaves only an intersection of two tables. It leaves only objects that are common to both of these tables. And inner join is not suitable for building datasets. If you think about inner join is basically a filtering operation. You need to use inner join only if you want to filter a bigger table by a smaller table. Let's think about some other joins. For example, so inner join is out, right join. Right join will ruin our second principle from left to right. Right join works in the other direction. So it treats right table as a main table and preserves all objects from the right table. So it is not suitable here. So right join is also out. What other joins do we have? Full join. What full join does? Full join looks for a match between two tables. It looks for an intersection. And it preserves not only all objects from the left table, but it preserves all objects from the right table as well. Let me show you how it works. Imagine that we have two tables. First table has 1, 2, and 3 IDs. And the second table has 1 and 5. If I perform full join, I will end up with 1, 1, 2, blank, 3 blank, blank, 5. Full join preserves all objects from both tables. Here it tried to find a match and it found 1 with 1. And then after looking through all possible matches, it just attached 5 without corresponding ID from the left table. That's how full join works. And from the first glance, it seems to be a very safe join, kinda, because it allows you to miss nothing. But we don't need this join as well. This join is out. Because if you want to have behavior like this, you want some additional objects after a join. It means that you have not defined your starting point properly. And if you need something like that, you have to come back to the first step and define your starting point. So you need only left join. And left join should be your default join. When you just building your dataset, you may safely use left join all the time. And all other joins should be used only on some special occasions. And you should understand what you are doing and why. Next principle, the fourth one. Aggregate before join. What does it mean? Let's imagine that you want to add a new column to your dataset. You want to add, let's say, number of products each customer has. In this case, we work with customers. Number of products. And we understand that in a database, you will not find a table that has this column. Most likely, you will find a product table. Product table. This table may look like this. It will have at least 2 columns. Customer ID and product ID. This table lists all products each customer has. For example, let's imagine that a customer with ID number 1 has 3 different products. So it will look like this: 1, 1, 1, and here let's say 1, 2, 3. And a customer with ID number 2, let's say, has only 1 product with ID number 3. These products might be, for example, online courses. In this case, customer with ID number 1 bought 3 courses, and customer with ID number 2 bought only 1 course. How to calculate this new column, number of products? Usually people think something like that. They think, okay, I have customer ID in my product table, and I have customer ID here in my dataset. So it is obvious that I need to join both tables. And they join product table directly to their dataset. And what happens after that? They end up with duplicates. Because in SQL, if your right table has duplicates and our right table has duplicates, in this case for the customer with ID number 1, these duplicates will be reflected in your resulting table. In this case, after performing a left join, you will end up with 3 duplicated records for customer number 1. And then people think, oh, I don't want to have duplicates in my dataset. My dataset should have only unique objects. Each row represents a unique object. But they still want to have their number of products column. And they understand, oh, I may perform count for product ID and use all other columns in my dataset in group by, just to get rid of these duplicates and to calculate the number of products at the same time. And they will end up with, in this case, 1, 2, 3, 4, 5 columns in their group by clause. And this is a very bad practice to calculate features like number of products by directly joining a table with duplicates and then grouping by all existing columns. There is a much better way to do it. Instead of joining a table like this directly to your dataset, create an intermediate table first. And this intermediate table should have an aggregation you want to have. In this case, a number of products. So our intermediate table will be the following. It will have 2 columns: customer ID and number of products. And it will look like this in this case. 1 and 2, customer number 1 will have 3 products and customer number 2 will have 1 product. And then you join this table to your dataset. Doing it this way, you get rid of duplicates right away. And you do not mess with your existing dataset. This way actually is much more straightforward. You need a new feature, number of products. And you calculate this feature first. You find the table in the database that has information you need, and you use this table to calculate this new feature. And then you add this new feature to your dataset. So aggregate before join. Now look at these two principles together: only left join and aggregate before join. These two principles are very helpful because they help you to keep integrity of your dataset. They help you to keep your starting point. Only left join protects you from losing anything from your starting point. If some information is not here, you just have blank. That's how left join works. Aggregate before join principle protects you from duplicates. Together, these two principles help you to maintain integrity of your dataset. Next principle, the fifth. Break your logic into steps. And I've already demonstrated this principle when we discussed the fourth principle, aggregate before join. Aggregate before join is a special case of breaking your logic into steps. Here, instead of joining our table directly and mix everything up, we introduce an intermediate step. We calculate the metric we want first. That's our first step. And then we join it to our dataset. That's the second step. This principle is very important, and it will help you not only in building datasets, but in using SQL and programming languages in general. And also, this principle is very helpful in life. If you break down a complex problem into a manageable steps, you can solve it. Now let's see how this principle might look like in code. Here is a query that calculates a number of products each customer has and adds it to a customer table. This query illustrates all principles we discussed so far. It has a defined starting point, customer table. It uses left to right logic. It adds new feature to the right of existing features. It uses only left join. It aggregates before performing a join. And it breaks logic into steps. First step is to calculate the number of products each customer has. And the second step is to join this table to an existing one. This query uses a subquery to break the logic into steps. Subquery, this part where we enclose a query in parentheses, allows us to break our logic into steps. That's the first step. And let's look at a more complex example that breaks logic into steps. Let's reveal this example. Whoa. This query looks very complicated, and it is. It's almost unreadable. Why? Because it uses subqueries to break logic into steps. Where is the first step in this query? First step is not the beginning of the query. First step is the most nested query, the most nested subquery, the innermost subquery. Here is the first step. And then you start to go inside out. Here is the second step, here is the third step, and here is the fourth step. That's how your queries look like when you use subquery style. And this style is not convenient and it is not practical. This style violates the intuitive order of reading. The intuitive order of reading is from top to bottom, not inside out. And here is the next principle. 6.1. Top to bottom. How to make our queries readable? How to make them follow our usual top to bottom direction? We can use something called common table expressions. And let me demonstrate you common table expressions together with ChatGPT. I will copy this query and ask ChatGPT, please rewrite using common table expression, CTE. Here is the new query. This query does exactly the same that the first query does, but this query is much more readable. Because now, if you look at it, the first step goes first, and the second step goes second. that allows you to follow top to bottom direction. Let's fix this guy as well. Now the order of steps is natural. It goes from top to bottom. We don't have to look for the innermost subquery. The query starts where it starts. Here is the first step, the second, etc. So in general, avoid using subqueries. They make your queries less readable. But in real life, you will almost never see queries like this. Queries that consist of series of common table expressions. Usually, you will see a series of create tables. In real life, when you work with large tables, using style like this, that is essentially a subquery, is not practical. Because anytime you add something to your query, you have to rerun the previous query. And in real situation, query could take a long time to run, and you don't want to wait every time you add something to your query. So, style that uses create table is much more common. Let's look at it. I will copy this query and ask ChatGPT, use create table instead of CTEs for each step. Drop each table just before it is created. Do not drop all tables in the beginning. And here I am so explicit about it because ChatGPT likes to drop all tables in the beginning instead of dropping each table just before it is created. Let's see what it generates. So now you can see the style that is more natural and is more common in real life. For each step now, we do not use common table expression, but we create a table in the database. We store it on a hard drive. And this is much more practical because now when you want to change something in your query, you don't have to rerun everything. And when you work at the current step, you can focus on the current step, and this current step uses a saved version of the previous step. This version is stored on a hard drive. You may wonder, why do we need this drop table if it exists before every create table? Because sometimes we do need to rerun everything and to recalculate everything. It is very common to do when the data has been updated and you want to recalculate your dataset. So you just rerun the whole query, and as a final step, you get the desired result. Sometimes you may also add something to the first step, and you want this change to be reflected in the next steps. In this case, you also need to rerun everything from the beginning. To summarize top to bottom principle, avoid using subqueries. And use common table expressions or create table instead. But usually you will see a combination of all these styles. Create table will be prevalent because it is more practical. Sometimes you will see common table expression inside of create table expression. And in rare cases, when the situation is simple, you may encounter an occasional subquery. But in general, use create table to introduce your steps, combine it with common table expressions if needed, and avoid using subqueries. Next principle, the seventh. Use ChatGPT. And I think that you've already seen how powerful ChatGPT is. When I asked it to rewrite these queries, it did a great job. So don't hesitate to use ChatGPT whenever it's possible. If you need to rewrite or refactor your code like this, go to ChatGPT. If you need to understand some complicated query, some complicated logic that was created by someone else, go to ChatGPT and ask it to break this logic into steps or refactor it like we did here. If you're just beginning your SQL journey and learning how to write SQL, don't hesitate to use ChatGPT as well. Use it as your mentor who is available 24/7. When you practice SQL problems on different coding platforms, ask ChatGPT for solution or for an explanation for solution you struggle to understand. It will speed up your learning tremendously. Now I want to show you how I write SQL, how I use principles we discussed so far, and also give you a couple more principles. Let's begin a practical part of this video. And next principle right away, it's use notebook as your IDE. IDE stands for Integrated Development Environment. It is a special text editor that has integrated feature that helps you to write code. And there are specific IDEs for writing SQL. For example, dbeaver. It looks like this. Here you may see an object browser where you can see all tables and or all fields that available in these tables, and you can write your code here. Select from and observe the results. And this is a traditional way of writing SQL. But the problem is that as a data analyst or a data scientist, after writing your SQL query, after building your dataset, you want to work with it somewhere. And usually you work with it in Excel or in Pandas. And I assume that today every data analyst or data scientist at least will to work in Pandas, because Pandas is very powerful way, and for exploratory data analysis it is much more convenient than Microsoft Excel or Google Sheets. And the most convenient environment to work in Pandas is Notebook. For example, Google Colab. Google Colab is one of products that gives you a notebook environment. And you can write your SQL queries right here in the notebook. Look, here you can write selects and you can send them to the database. And if you do it like this, you don't have to switch between two environments, between something like dbeaver and something like Google Colab. When you write SQL right in a notebook environment, you get your results in the format of a pandas data frame. And these data frames are ready to be analyzed. You can plot graphs or do machine learning or do some other analysis. It is very, very convenient. By writing your queries in the notebook, the transition between database and pandas is very smooth. You don't need to export your data in, let's say, a CSV format after writing SQL queries here. You can use them right away after writing your query. Also, you don't need to have separate SQL scripts. Usually, when you write SQL like this, you store your queries in text files that you name something like script.sql. And this is not really convenient because you should have at least two files for the project. You should have your SQL script in .sql format and your notebook. And it is harder to manage. If you write your SQL right in the notebook, you have everything in one place. And it is very helpful to understand something in the future. You don't have to look for a SQL script and to try to remember what you were doing. Everything is documented here in the notebook. In the notebook environment, you can document your queries in much more human-friendly way because notebooks allow you to write markdown like this. Your document may have a structure and you can add just regular human text to describe your queries. When you write a complex SQL query that has multiple steps, you can store each step in a dedicated notebook cell. It will help you to break your code into steps and to unload your mind. When you write something like this here in environment like dbeaver, you have to deal with this long script and it distracts you, it overwhelms you. Here you may divide your code into cells. You can add a markdown comment to each cell and make your document easy to read and to manage. Using a notebook as your SQL environment has some downsides. For example, a regular notebook doesn't have an object browser like this, where you can see all tables. But you can just query the system table that stores all your tables, like here. You can access all objects in your database through SQL queries, just like that. More advanced notebook environments provide you with object browsers. For example, my favorite, DeepNote. I use it to live code with my students. DeepNote has an integration that helps you to connect to databases. And here I have some database connected, SQLX. And here this environment allows you to insert SQL cells, SQLX, and here you have view schema. You can click view schema and you will see all tables that this database has. But even if your notebook environment doesn't have an object browser and you don't like this style when you query these system tables directly, you can use something like dbeaver just for an object browser. you can have dbeaver opened in the next window and use it to understand what your database has. And after you understand what it has, you can switch to your notebook and write your SQL code here. Another downside of using the notebook environment to write your SQL queries is that a regular notebook environment does not provide you with syntax highlighting for SQL. dbeaver, for example, highlights SQL operators and keywords. Here we write our SQL by creating Python strings, and we have no highlighting here. But for me, it is not a big deal. I'm really comfortable to write SQL code without syntax highlighting. More advanced environments like DeepNote provide you with syntax highlighting, of course. Select star from income, for example. So here you may see that select and from are highlighted. For me, there are more upsides than downsides, and that's why I recommend to use Notebook as your IDE. And I especially recommend to use Notebook environment when you perform test assignments from potential employers. When you are given a test assignment and they ask you to write a couple of SQL queries, I recommend to share the solution for these questions in the form of a notebook, because notebook is much more convenient than a Microsoft Word file. In the notebook, you can generate data if you are not provided with data. You can write all your queries and to demonstrate that they actually work. You can break down your queries into steps and you can explain every step with a markdown comment. And this will impress your potential employer. So I recommend to use a notebook environment to show off your SQL skills. If you will use notebook environment for completing test assignments, you will stand out among people who send Word files as their solutions. Okay, now let me walk you through this notebook, show how everything works here, and demonstrate my principles in action. You can use this notebook as your playground, because this notebook is fully autonomous. It does not require to install database anywhere. This notebook installs database right here on Google Colab. I will demonstrate you everything, and if you want, you can find the link to this notebook in the description and use it for your experiments and learning. The first section of this notebook installs Postgres. Let's run this cell. This cell contains a bunch of commands that install Postgres on Google Colab. Google Colab gives us a virtual machine, and we can install anything on this machine, including databases. And this cell does exactly that. It installs Postgres to this virtual machine, and we can then use this Postgres to play with it. Let's check if everything is okay. No errors here, so I conclude that everything is okay, and I can clear this output to not scroll it every time. And you don't have to understand how this cell works. Just use it and that's it. These are Linux commands that install Postgres. That's it. The next section setups the database, and it just prepares it to restore the database from dump. Let's run these cells, and you don't have to understand these commands completely, and I don't understand them as well. I just set and figured out how to do it here on Google Colab. I googled, I used ChatGPT, and eventually I figured out what commands should be run in order to set up this database and to restore the database I want. And the next section downloads a dump and restores a database from this dump. In this notebook, I use very famous database, Postgres sample database, DVD rental database, that you can find here on postgresqltutorial.com. In my notebook, I download the dump using curl. Curl is a Linux program to download things from the internet. I download this dump. Let's do it. Here you may find it here. We have downloaded it. Then I have to unzip it. We can see that it was unzipped. And now this dump is ready to be used to restore the database. I run this command, and this command restores the database. Now the database should be available in my Postgres that installed here on Google Colab. Now we are ready to connect to our database, and we will use SQL Alchemy to connect. In SQL Alchemy, to connect to the database, you create engine, and to create engine, you have to specify credentials of your database. And credentials are the username, password, address. In this case, our database is installed on this machine, so we use local host, but it could be an IP address or a URL. We specify port, a technical thing you have to specify, and the name of the database, DVD rental in this case. I run this cell. Then I import libraries, pandas and numpy, libraries we use to work with data in Python. And in this cell, I create the select function that I will use to query my database. This cell has a weird syntax, but we don't have to deal with it. The important thing here is that this function returns you a data frame, because the main function that we use here is read SQL query, and this function comes from pandas. It allows you to send a query to a database and have your results in a format of a pandas data frame. So this function returns you a pandas data frame, and you can do whatever you want with this data frame. And now we are ready to test our setup and send some queries to the database. And as I said, I will write my SQL queries in a form of simple Python strings. In this case, I use these triple quotes to be able to have multiple lines in my strings, because SQL queries could be very long, and I want to be able to format them to increase readability. I don't want to have them like this in one line. I want to be able to do this, create a new line. Triple quotes allow me to do that. So here is my query. I store it in a variable, just a string, and then I send this SQL query to the database using the select function. select function sends it to the database and gets the response and returns it to me in a form of a pandas data frame. So let's run it. And you can see that it worked and returned this table. This table lists all tables that my database has. And this is it. Our setup works. You can query the database from the notebook. And you can query whatever database you want, not only Postgres. SQL Alchemy allows you to connect to every possible database. And this way does not depend on any special integration. You can use SQL Alchemy even in Python scripts if you want. And in any notebook environments that have no special integrations with SQL databases. So this approach will work everywhere. And the last technical section of this notebook is creating tables. Here I created a function that is able to create tables. Select function can only read data from your database. You cannot create something using this function. If you want to create table, you have to use this. And if you look inside of this function, you will see that it uses slightly different syntax. It uses execute to run SQL query. And this execute allows you to perform writing operations. And if you want to create a table, you have to use this function. And here is an example. I will run this function. I will create this SQL query, and it just creates a sample table with only one row and the value of 1. Create SQL. And now I test it. Now I write a normal select query and send it to the database, and in return get my newly created table that has only one column and only one row in it. Okay, now let's write some SQL. And the question we will be dealing with is calculate the number of rentals each customer has. Here I inserted the diagram that describes the database, and let's look at it. We need to calculate the number of rentals each customer has. You can see that we have the customer table and the rental table. So we will use them to calculate this number. And we have to start with a starting point. In this case, the objects we are gonna analyze are customers. So our starting point should be all our customers. And let's look at this starting point. I will start to write my query. SQL equals select star from customer. And here I will add limit 5. Limit 5 will allow you to download only 5 rows from this table and not the whole table. Sometimes when you work with real tables, they are really large, and if you try to download them, your notebook environment will be crushed because you will run out of RAM. Here, your RAM is limited, and you cannot hold the whole table if it is large in your RAM. So when you work with real tables, always add limit 5 to your queries when you just writing your query and debugging it. SQL equals select star from customer limit 5, select SQL. Here is the table. And here I want to discuss a very important principle that is about how to write your SQL queries. Never write a long SQL query without testing it. You see here, I know what I want to accomplish here, but I'm not going to write it right away. I will write it gradually. Imagine that you are building a house. You start with a foundation and then you build story by story, and each story stands on top of the previous one. This approach will save you a lot of time and a lot of debugging. When you run a long SQL query, run it and get an error, you don't know where to look to find this error. But if you write your SQL query gradually, you know that the error could happen only in the last part you've just added, and you can fix this error quickly. If you deal with the long query that you've never tested, it's very hard to find the error. And I recommend to use this approach everywhere, including a job interview. When you are asked to write some SQL query, break it down into steps and start with the first step and test it. By solving interview questions this way, you will get more and more confidence on each step, more and more momentum, and this will allow you to solve complex SQL problems in a stressful environment. It is almost impossible to find an error in a long SQL query during a job interview because you are so stressed, and when you look at a long SQL query, you just get overwhelmed and it paralyzes you. If you build it gradually, step by step, it is much more likely that you will be able to solve a complex SQL problem during a job interview. Let's write this principle down. Nice. Do not write long SQL queries without testing. That's a very important principle. Okay, let's continue to work with this problem. Number of rentals each customer has. I look at my starting point here. I understand that I want to calculate this feature, number of rentals, for every customer. So I need all customers from this table. But let's check if customers are unique in this table. Here you can look at this diagram, and customer table has this small asterisk here that denotes a primary key, and primary key guarantees you all unique customer IDs. But that not always is going to be the case. So when you define your starting point, check that all objects in your starting point are unique. How to check that we have only unique customer IDs in this table? We can calculate the number of rows in the table, and we can calculate the number of unique customer IDs and compare these two numbers. If they are the same, all customers are unique. If not, then not. Let's do it. I will copy this query. I will paste it here, and I will start from testing it just to ensure that everything is okay and I have my foundation. Then I start with calculating the number of rows. I will do it like this, count star. And again, I will test it. I will test that everything is okay and I get this number. Then I will calculate count distinct customer ID. Let's run it. And you can see that these numbers are the same. It means that all customer IDs are unique in this table. And we can continue. For this example, I want to actually define my starting point. I don't have to do so in this case. I can directly work with my customer table. But let's imagine that I had to perform some manipulations in order to get my starting point, some filtration, for example, or some cleaning. So let's create the first step explicitly. And I will start with using common table expressions, and then we will rewrite the whole query to create table style. I will copy this query, run it. And let's imagine that I need only customer ID and customer's first name, and that's it. Let's select these two fields here, customer ID, and it is convenient just to double click or double tap the name of a column like this, then use Command C to copy it to save yourself some typings and typos. Let's test it. Worked. And now I will create a common table expression out of this select. It is not necessary, as I said, but I want to make it explicit for this example. With customers as I enclose the whole query here, and I don't need limit 5 in this query because this query creates my common table expression, my kinda temporary table that I will be able to refer in later queries. And here I will select from this new table. Select star from customers, run, and I did not use limit because I know that the table is not that big and nothing bad will happen with my Python, with my RAM. So I can see that everything is okay, that my common table expression works, I have no typos, and I can continue to build my query. What is the next step here? The next step is to calculate a number of rentals for each customer. And I will emphasize the force principle here, because I can just join my rental table directly to my starting point, customers table. But I will aggregate it before join, because this table, rental, it stores rentals of our customers, and each record represents a fact of rental. It means that every customer can have more than one rental, and customer ID in this table is not unique. Let's look at it. SQL equals select star from rental, limit 5, check if everything is okay, and I will check that customer ID is not unique in this table. I can do it same way I did it with the customer table. Count star, count distinct customer ID. And you can see that the count of rows is 16,000 and the count of customers is about 600, and this number 599 corresponds to the number of all customers in our database. Now let's calculate the number of rentals for each customer. SQL equals select star from rental, limit 5, select SQL, that's my template, and I will group by customer ID and count rows. That's how I get the number of rentals for each customer. Group by customer ID. Let's check. That's the metric I want, and I will rename it to rental CNT. Customer ID, rental CNT. Now let's add this step to my main query. I will add it as the second common table expression. Let's copy this whole query and add another common table expression. I will name it rental AGG S, and here I will paste this query. And I will check it right away. I will copy this name, this alias, and check if everything is okay. Now I can see that I have access to this table, and I have access to this table as well. Now I'm ready to perform a join. I will use left join because left join is our default join, and I will do it like this. Select star from customers, left join, rental AGG on, and the condition is customers, customer ID equals rental AGG dot customer ID. From my starting point, I want to have all columns, and from rental AGG I want to have only rental CNT column. Let's check it. Here it is. This query follows almost all of my principles. Let's see. The first one, define a starting point. Our starting point here is the customer's common table expression. Left to right, it builds our dataset in the left to right fashion. We started with a starting point and we added this rental CNT column to the right of our initial table. Only left join. Only left join. Left join is your default join. Aggregate before join. I aggregate the rental table before joining it to my starting point. Break your logic into steps. My whole logic is broken into steps. First step for the starting point, second step for aggregating the rental table, and the third step is to joining them together. Top to bottom, I use common table expressions to write my query. So first step goes first and so forth. Use ChatGPT, not applicable in this case, just a simple case to demonstrate my principles. Use Notebook as your IDE. Yes, I'm writing everything in the Notebook environment. Do not write long SQL queries without testing. And I followed this principle while writing this query. I wrote it gradually, step by step. I even broke it down into separate cells. Here is the cell that contains the second step. And then I added it here in my main query. And here I want to discuss another very important principle. The tense. Use meaningful names. Very often in SQL you have to come up with names. In this query, for example, I named my first common table expression customers, and my second common table expression I named rental AGG. Very often you will see that people use something like this: CTE1, CTE2. Never use names like this. They are meaningless and they are very hard to manage later on. Don't use names like CTE1, CTE2, and so forth, T1, T2, and so forth, A, B, C, D. These names are meaningless, so don't use them. By using names like this, you will always have to remind yourself what letter or what number was assigned to what. You will have to always look at your query and remind yourself, oh, I named aggregation of my rental tables CTE2, for example. It's very hard to keep in mind just numbers. You have to keep this map in your mind, which number is connected to what step. By using meaningful names like customers or rental AGG, you document your steps, you document your objects. You create a handle, a mental shortcut for the step you have. And it helps you to manage your query, to manage your code. Same is true for using aliases. In SQL, you may assign an alias to a table. For example, here I may assign an alias C to my customers table and an alias RA from first letters, RA to my rental AGG table. And here, instead of using the full names, now I can use these aliases. And I have to change them here as well. CRA. These aliases I used here are good because they reflects the objects they were assigned to. C is the first letter of the customers table, and RA is two first letters of rental AGG table. But very often you will see something like A and B, or T1 and T2. do not use aliases like this. It is the same mistake as with meaningless names. It is very hard to manage query with this alias style. You have constantly remind yourself what alias was assigned to what. Use shortened versions of names of your tables, like first letter or first couple of letters. And also, there is nothing wrong with using full names of your tables. By using full names, you make your code as explicit as possible. When I use aliases like this, I have a small life hack to help myself. My first table, I usually name T. It is the same as naming your main pandas data frame df, because you know that in your SQL query there should always be the first table, and I usually name this table T. I give it an alias T, and it helps me to think about my query in more intuitive way. But this style is personal and I do not force you to use it. Using aliases is very personal. Just follow these general guidelines. Use meaningful names. Before going to the next principle, I want to show how to achieve the same result as we achieved here with common table expressions, but with create tables, as we discussed previously in this principle, top to bottom, common table expressions or create tables. As I said, create tables are more practical way to build datasets. Let's look at it. In this query, I have 3 steps. The first step creates our starting point. It selects all customers from the customer table. The second step aggregates customers' rentals. And the third step joins aggregated rentals to the starting point. I'm gonna replace common table expressions with create tables for the first 2 steps. Let's do it. I will copy the query that creates our starting point. And here I will type SQL equals insert this, and I will check it first of all that everything is okay. Select SQL, should be okay. Yes, then I will remove this limit and I will add create table customers as. And now, in order to create table, I have to use create function. Remember, here we have a special function to create tables. I will use this function, create SQL. And now I will check if this table is created. SQL equals select star from customers. And let's use limit 5 as well. Limit 5. We can see that this table has been created. And by the way, this create function, you can use it to change existing tables, not only to create them. You can use this function to insert or to delete rows in your tables. The difference with the select function is that select can only read data from the database, and create function can change the data. The first step is almost done. The only thing that is missing is drop table before create table. And we need it because imagine that you decide to add a new column here. And you need to recreate this table. And if you try to run this query as it is, like this, database will say you that relation customers already exists. In SQL, you cannot override tables just like this. You have to drop them explicitly. Let's do it. Drop table if exists customers. And here I will put semicolon because now we have two separate SQL queries. And when we combine several queries in one script, we have to separate them by a semicolon. Why do we need if exists? If exists helps you to run this query drop table when table does not exist. Because if you will try to drop table that does not exist, drop table will fail. And if exists protects you from this problem. So even if the table customers does not exist, you still can try to drop it. That's what if exists gives you. Let's run this query. Now it should work. And that is very convenient. Now at any point you can return to your first query, to your previous query, and change something in this query. Add some other field, just rerun it, and then use this step in your next steps. Let's do the second step. I will copy the query that creates the second step. Paste it here, SQL equals limit 5, just to check, select SQL, everything is okay, and I can add drop and create expressions, and I will copy them from here, and then just replace them with this name, rental AGG. Here I will use drop table if exists rental AGG, create table rental AGGs. Here I will run this cell, create SQL, and we'll check. Select star from rental AGG limit 5. Everything is okay. And now the last step. And the last step I can just copy from here. All table names are the same, and I will just run it. Let's add limit 5 here as well. Limit 5. Select SQL. You can see it works. And here in the notebook environment, we can use Markdown features to structure our steps. Let me show you. Here I have a section, create table, and I'm going to create nested sub-items for create table to help to structure these steps, to outline them. Let's call it first step, the starting point. Second step, step 2, aggregate or rental counts. And a third step, the third step, step 3, join rentals to the starting point. And you may see that your query is structured. All steps are documented. Can you see the power of the notebook environment? It's much better than having these long scripts, or real SQL scripts are much longer. And it's really hard to deal with them in this form, or in the form of a SQL script, a simple text file. That's how usually people work with SQL scripts. It is much better to work with your queries in this way. Here you can break everything into steps and outline them, and it helps you to unload your mind. Here, when you arrive at the third step, for example, you can focus entirely on this step, and you can forget about how customers is created, how rental AGG is created. When you look at a SQL query in this form, you are constantly distracted by the rest of the query. And by breaking it down in this way, you help yourself to focus and to be more productive with your SQL queries. Also, this way of writing SQL queries allows you to present your work. And as I said, it's a very good way to format your test assignments this way. When you get an assignment from a potential employer, a SQL assignment, I recommend to write it in this way, to use the notebook environment to break everything in steps, and also you can provide explanations for your steps. You can add additional markdown cells and write here your comments. And you can turn your test assignment into a tutorial, and you will stand out if you will do it like this. Most of the times you will want to create a table for the last step as well. And if you create a table for the last step for your final data set that you will work somewhere, either in Excel or here in the notebook environment, you may want to drop all previous steps because you don't need them anymore, because all previous steps just lead to the final data set you are building. So let's create a table out of the third step and drop tables for the first step and for the second step. I will do it right here in this query. I will copy this drop and create expressions, paste them here, and I will call this table drop table, if exists, my dataset. My dataset, and create table my dataset. And I will get rid of limit 5 because I want to store the whole result of this query. Let's run it, and I need to use create SQL, check, select star from my dataset, select SQL, everything is okay. And now I'm ready to drop these intermediate steps. Let's do it. SQL equals drop table, if exists, first table is the customers table, customers, and the second table is rental AGG. Where is it? Rental AGG. And I can run this query, create SQL, and I can check that these tables are not available anymore. Select star from customers, select SQL, relation customers does not exist. And it is a good thing to drop steps, to drop tables that you don't need anymore, because when many data analysts work in a database, it could be a problem. You can encounter problems with the space that is available in your database. So it's a good thing to drop tables that you don't need. After creating your dataset, drop all tables that you don't need anymore. And here I want to shortly comment on the question we worked here in this example. Number of rentals each customer has. Imagine that this feature, a number of rentals each customer has, is not a part of a data set, but just an ad hoc question you received as a data analyst. And you have to quickly look number of rentals each customer has. In this case, you may decide to go straight to the rental table and just perform this, just the second step, because this step actually gives you a number of rentals each customer has. But this approach will be incorrect, because the rental table is a transactional table. It stores transactions of your customers. And some customers can have no transactions. And in this case, if you base your logic on the transactional table and nothing else, you may miss the customers who has no transactions. And if you need to report, let's say, an average number of rentals each customer has, you have to average this whole table. In this case, you will average only customers who are active, and you will miss on customers who are not active. And sometimes it could be wrong. So even if you are asked to calculate something like this, not as a part of a data set, you still need to start with a starting point. You still have to first find all customers your company has, and then join aggregated version of your transactional table to this starting point. And you will see, for customers who has no transactions, you will have blank, you will have null. And you have all control over this question this way. You can, let's say, replace this null with 0 and calculate the average. And average will change. The average will be smaller than if you just calculate this average on the transactional table only. So just be aware of this thing. When you deal with a transactional table, do not use it directly. Firstly, find all objects you are analyzing, and then join transactions associated with these objects to these objects. And that is a correct way to work with questions like this. Okay, the next principle. 11th. Check yourself. There are two ways to check yourself. The first one is check your totals. And the second one, look at single objects. Single objects. Let's discuss checking totals. Imagine that a company has sales that totals to $100. So that's our total sales. And you, as a data analyst, asked to break these sales down by country. And let's imagine that we have three countries: country A, country B, and country C. And after breakdown, you get the following numbers. For the country A, let's say $50, for country B, $30, and for country C, $30 as well. Can you spot the error? If you sum up these numbers back, you will get $110. And it does not correspond to your total sales. It means that you made a mistake somewhere in your logic. Probably something got duplicated. And it happens very often with data analysts and data scientists, especially if they don't know these two principles: only left join and aggregate before join. Because, as you remember, these two principles protects us from losing something from our data set and from having duplicates. If you follow these principles, chances are that your totals will be okay. But I still recommend to check your totals time after time, especially in the very end, when your data set is ready and you are going to start data analysis or machine learning. I recommend to check that data set is okay, that you have no duplicates, that you have not lost any objects from your starting point, and make sure that everything is okay. Let's look at an example. In our query, we calculated the number of rentals each customer has. So we broke down rentals by customer. Let's check if our totals are okay. First, I will calculate the overall number of rentals. I can do it like this. SQL equals select star from rental, limit 5, select SQL, and here I will just calculate the number of rows, count star. That's the overall number of rentals, the total number of rentals. And in this table, in my dataset, I break this number down by customer. And theoretically, if I add up all number of rentals for all customers, I should get back this number. Let's check it. SQL equals select star from my dataset, limit 5, select SQL, and now sum, and the name of the column is rental CNT. Let's run it. And the problem is that our numbers, our totals, do not match. And here you may ask, probably they should not match, because we discussed that transactional table like rentals should not have transactions for all customers from our customer table. Probably this rental table stores some strange transactions that are not about these customers. It could be the case. So let's check it as well. Let's check that all these transactions are about our customers that are present in our customer table. How to do it? Let's do it this way. Select star from my dataset, limit 5. Select SQL. And I know that all customers in this dataset should be unique. Let's check it as well. Count star count distinct customer ID. Now I know that all customers are unique and there are 599 of them. Now let's look at the rental table. Select star from rental, limit 5, select SQL, and I will calculate the number of distinct customers. Distinct customer ID. And the number is the same, but what if it is just a coincidence? But these are different 599 customers. We can check it. I can do it this way. I can take my dataset table and select customer ID from here. Select SQL. And now I want to check if all these customers are in the rental table. I can get all unique IDs from the rental table. I will do it this way. Distinct customer ID. Select SQL. And now I can join these two tables and check how many customers from my dataset are present in rental table. And in this case, I can use a subquery because it is a very simple case. My dataset, left join. I will copy this code. Left join. And I will call it rental. This I will call T as my first table. As I mentioned, I like to name my first table T. And here on T customer ID equals R customer ID. And I will use limit 5. Select SQL. Column reference customer ID is ambiguous. Yeah, because here I have to specify an alias. T.customer ID R.customer ID. I want both of these columns. So now the first column is from my dataset and the second column is from the rental table. And here, by looking at only 5 rows, I may see that we have these customers in the rental table, but we have to check all 599 of them. And you can do it by calculating a flag and taking an average of this flag. That's one of my favorite tricks in data analysis, by the way. So here, what I'm going to do, I'm going to write case when customer ID is not null, then 1, else 0, and as flag. Let's call it just flag. Or we can follow, use meaningful names and call it present in rental. Let's look at it. So now we have a flag that has a value of 1 when the customer is present in the rental table, and it will have 0 if customer is not there. And now I can calculate the percentage of customers who are present in the rental table. And I can do it like this. I can just take an average of this expression. And I can see that the average is 1. It means that all customers are present in the rental table. So we are back to this problem. These numbers should be the same. We have a problem. How to understand where is the problem? You have to look at a single object. And here, if I scroll up, I may notice that some of my customers, for some reason, have none in this column. And it is strange. So let's look at this customer, Jeffrey. Let's copy his ID and select all information about this customer from the rental table. Select star from rental limit 5. Check my template, and then where customer ID equals 328. Let's look at it. Here it is, and I can get rid of limit 5 just to download all rentals associated with this customer. Here are all rentals this customer has, and I can calculate the number of these rentals. I can do it in pandas, by the way. When you start to debug your query, it is convenient to do it in pandas because you have more flexibility. Let's save the results of this query into a variable df. And now I can easily calculate the number of rows in this df. I can run len df. And the number is 23. So this customer should have 23 rentals. And for some reason, he has only none. He has 0 rentals. What happened? We have already checked that all customers are present in our rental table. So the problem should be in the query where we aggregate our rentals by customers before join. Let's find this step. Here it is, step 2, rental counts. And let's examine this query. And if you look at it at the first glance, it seems to be okay, but then you spot limit 5. And you understand that limit 5 should not be here. Because when we build a dataset, we want to have all rows in our tables. And limit 5 we use only for debugging purposes. And here it was just my mistake. I forgot to delete it from here. And by the way, it was not intentional. I did not plan it. And I'm really happy that something like this happened. And my demonstration of principles about checking yourself became more live. Let's delete this limit 5 from here. And rerun these expressions. So I recreated table rental AGG with all rows now, without limit 5. And now I will recreate my dataset table. Customers does not exist, and yeah, because I dropped it, so I have to create my customers table one more time, and let's rerun all the steps. Now it is okay. Let's look at the table. Now we don't have nones here, and let's perform our check. So select SQL count 16044, and now sum up all rental CNT from my dataset. We have the same number. The bug has been fixed. And we observed all principles of checking yourself, checking the totals and looking at single objects. Let's conclude this by looking at Jeffrey and see if everything okay with Jeffrey. Let's run these cells. Yeah, here is Jeffrey, and we see that Jeffrey has 23, but here we select from rental table, and let's select from our dataset. Select star from my data set limit 5, select SQL, and let's add where close, where customer ID equals 328. Let's look. Here is our good old friend Jeffrey, and he has 23 transactions. By the way, when I pick some object randomly from my dataset and I continue to work with this object while I'm building the dataset, I like to call it my debugging body. So Jeffrey is our debugging body here. And here I want also to comment about storing this table in the data frame. Yeah, so in this case it not necessary. I've just demonstrated how you can switch between SQL and pandas, and this switch is really smooth. Sometimes your debugging process is harder, and it could be more convenient to use pandas to just quicker discover what happened. Yeah, here, like if you think about it, to calculate the number of rentals Jeffrey has, you can do it just like this. You can select star and here just count star, and you will get the same number. So no need to save it into pandas. It was just a demonstration of what is possible. Okay, we've covered almost all of my principles. Only 2 principles are left. Let's look at them. And these principles are quite short. The 12th principle. To hell with optimization. When you build a dataset, first of all, focus on the dataset itself. Make sure that the data in the dataset represents your objects correctly. Focus on the logic of your dataset. Focus on numbers. Make sure that you have no mistakes. Optimization is the second question. Very often you don't need to optimize your query at all, because you need the dataset the query builds just once. And after that, you just forget about the question you were analyzing. Optimization is necessary only when you want to build this dataset regularly. You want to update it and you want to maintain it. And it is not always the case. Optimize your query only after you understand that you are going to use this query regularly. Do not optimize it right away. Don't waste your time on that. Focus on numbers, focus on logic, and make sure that your dataset is correct. So on the first phase of working with a dataset, to hell with optimization. And many people focus too much on optimization and do it prematurely. So do not do it. Be more practical. And finally, the last principle, 13th, the fun one. To hell with upper case. You may have noticed that I do not capitalize keywords when I write my SQL queries. I don't care. I think it is a waste of time to make them capital manually, to press caps lock or to use shift in order to type them capital. It doesn't matter. The code is readable in this form as well. And if you want, for some reason, to have these keywords uppercase, you may find a SQL formatter, for example. You can Google SQL formatter and open something like, let's click the first link here, and there is a SQL formatter. You can bring your SQL query here and ask it to format. That's it. You may see that now all words or keywords are in uppercase. So don't waste your time to do it manually. And some environments provide you automatic beautifiers or prettifiers that can do it right into your environment. And that's the last principle, to hell with uppercase. This is it. Wow. 13 principles. I enjoyed making this video so much. Thank you for watching. Subscribe and like this video. Also, I offer coaching, and you may find a link to my website glebmikhailov.com in the description, and contact me there. I offer coaching in data analysis and data science. I may help you to start your career in data analysis or data science. And also, if you are already a data analyst or a data scientist, I can help you to develop your career further. Thank you for watching. See you in the next one. Bye bye.